So let's start. I'm posting the URL to Etherpad in the new chat window. And last week I've been working on the async implementation based on SAM-JLBA branch, which is still work in progress. But feature-wise, it's quite complete. It's able to support, offers what I need to implement the on the tree. I'm still working on the merge support. And also I've been doing some code reviews. And that's me. Videk.
Yesterday I sent the part 0 of the backfill effort. Here is the link. Now I'm well. I tried also to search to self-review it a bit. Now I'm poking with unit testing for the backfill machine. That's me.
Thanks. Trumei.
Yeah, I'm still implementing the B tree node, and so first I have to understand the LBA tree implementation and try to figure out how the code can be reusable. Yeah, so still working in progress.
I suspect that the closest you're going to get to reusable code there is the btreeNode.h thing. It factors out things like generating a split node or generating merged nodes or shifting a subrange of indexes over. I think the implementation itself, however, does a lot of fancy footwork regarding the physical addresses, which I think won't be as useful. Up to you, though. Whatever you think you can factor out usefully or cleanly will be good.
So, Kefu, Sam said that your code layout.h is the good foundation. But
well, if you've had a look at my code, you'll notice I did a thing where I just kind of wrote an iterator interface over the raw byte ranges in the node. I don't actually know whether that's a particularly popular or common way of doing it, and I was going to take a look at Kifu at the code from Absil Kifu added to see whether that's cleaner.
Yes, I think it's a cleaner, and
I'll probably do that. All it really affects is the layout in memory, though. It doesn't really affect any of the tree operations.
Yes, but regarding to the copy and write thing, I think we need to adapt it to our needs based on the LBA tree.
Oh no, I meant just the layout.h file. I haven't looked at the rest of it.
That would be helpful.
I meant as opposed to doing the thing I did with the iterator, which may not be the cleanest or most portable thing.
Yes.
Yeah.
If the size of the cells and the keys are fixed, that will be a lot easier to use the layout.h.
I mean, what I did was essentially a less general, less reusable version of it. So.
Yeah, that's.
Oh, by the way, Trumei, regarding to the performance test, I will reply you ASAP. I still think I generated that kind of numbers using the CBT.
I think you were probably just using the CPU usage, including any busy waiting. But the thing is, for Crimson, it's only running on one core. So what we're doing is we're overestimating the CPU usage for Crimson. And even under those conditions, it's still faster than Classic, right? Because Classic uses several cores. So I don't know how much time you really want to spend on getting better numbers than that. You can probably just do that, and that'll tell you what you need to know.
But actually, if you want to get a better number or more precise number, probably you can take a look at the Inshin's reply. I'm not sure you are in that loop. I forwarded the mail to you. Inshin mentioned that SeaDB guys are using a different metric for measuring the CPU usage, which is
use the metric in SeaStor, in SeaStor, right? You mean
yes.
But not directly. not for the direct numbers, just to ensuring that your setup actually saturates the Crimson instance.
Okay, so it's not
that there is huge level of indirection here. All you want, the primary metric I believe you want to expose is cycles per operation, cycles per op. However, as SeaStor does busy waiting, the cycles per op, the number of cycles burned per single operation could be actually higher if Crimson isn't fully saturated. So Scylla guys, as far as I understood, made some kind of internal metric that allows how often, how frequented the busy loop really is. So if you can get access to it, you can, and if you see it's too frequented, then you can add yet another instance of Rados bench. That way, finally, you get the variable cycles per op. But to be honest, there might be much easier approach. I was usually sticking to just adding another Rados bench instance till the total number of the total IOPS started being constant, which means saturation of Crimson. My rule of thumb is that on my machine I need two or three Rados bench instances to saturate Crimson on SeaStor doing 4K random reads.
What's your storage is? It's a NVMe or a SSD?
No, SeaStor. It's just memory.
Oh, SeaStor. Sorry. Okay, it's on SeaStor, so it's identical, I guess.
Another caveat I have met is that if I burn CPU too long time, it will degrade its frequency because it may be too hot.
Throttling.
Yeah, it's throttling. Yeah.
We ran into very similar issue on Incerta 07. It was okay for Crimson. It was popping up as well, but it was terrible for RocksDB, some low-level benchmarking of RocksDB. Anyway, we ended with just turning off all the power saving power management features in CPU. You should be able to do that in BIOS or something like that.
It's a real problem. So, like, there's the short term. How do we solve this for benchmarking, and then the longer term, this actually does waste power problem. So we do need to address that this actually does waste power problem at some point.
What do you mean waste power?
Pegging the CPU at all times wastes power. It literally wastes electricity. Like with the OSD is. So we do need to solve it, but for benchmarking, yes, you can just disable the power management features.
I have a comment here, which is based on my experience with ARMs, not with 86s. But if you're tweaking the frequency, then you still have some guards, some guarantee against burning out totally, but most of the thermal guards are off, which means that there is a chance you will just burn down your CPU. It's not something that I would do.
There's a lot of discussion with Intel about that. Yep, Mark Nelson was discussing that with Intel many times actually. Maybe preferred. We might ask him on today's Rados sync. I don't know the details, but I can recall that he was mentioning that issue at the time.
Okay, and I know it's a real issue because I had to get around it when measuring ARM performance. on another system.
On inserter we bumped down we set constant CPU frequency, but we bumped it down pretty significantly, maybe 10, maybe 20%.
Okay, that's a start. No guarantee that you don't overshoot, but it's a start. But another question, we might want once we do what Radek suggests, to just saturating the OSD, we might want to see what are the numbers, calculate if it matches what we calculate when we take into account the time spent in the busy loop, in the idle loop, and see if we can just use that, do a calculation based on the numbers from the idle loop instead of just having to saturate the core.
Not sure when I understood you. Do you mean observing the internal busy weight related metric and use it to add further radius bench instances, or somehow derive the number of the cycles per off on the basis of this metric?
Yeah, sorry, I wasn't clear enough. What I'm suggesting is two things. First, just to mention it, publish the numbers as part of the CBT results of test or whatever test result we're using. Publish the number of the idle loops. And the second thing is trying to find out if this is a good, if it's a number we can use instead of just, if the numbers match. If you calculate the CPU per op when you're fully saturated and compare it with what you get without saturating the core, but with taking into account the numbers from the idle loop to see if it matches. If it matches, we can then we don't have to saturate a core for the patient.
Okay, makes sense. But the step number 0 is just to start acquiring the metric and storing it inside results, just for validation.
And the min-max frequencies, by the way.
Ronan, could you add
I think
add
this
a
is already
card
made.
in the Trello to make sure we don't forget it?
Yep, good idea.
Yeah, I do it immediately after the
I think the
meeting.
step 0 is the well defined at the moment, just to add a metric to extract the information from the PP. Yes.
I will.
Thank you.
CBT already harvests a lot of data about nodes, about environment. I'm not 100% sure, but I'm going to guess it already records the frequencies.
I think so. And I think
likely
I'm now also making it easier to add such kind of metrics to CBT.
So currently the metrics only can value the CPU used in the SeaStor, right? In our code, there is no metric, and so it is not accurate for our permission. And so all you get is just to use the saturated to trigger the saturated OSD performance. Use more client side to saturate the OSD, saturate the CPU.
I think so. It depends on what you expect from the result. If you are expecting a saturated load and push Crimson to its limit, then we probably could use the tools and to figure out what's the right load to add on top of a Crimson OSD and the classic OSD if you wanted to do a apple-to-apple comparison.
Okay. But currently CBT gave the CPU usage just for one instance, right? Oh,
But CBT is configurable. You could add more instances on.
Of Radius Bench, yep.
Yes.
All you need to do is to tune the YAML files in the test CBT directory in the main Ceph repo. At the moment, well, if I recall correctly, we can configure. Okay, there are two places. First is about the number of clients. I mean, Rados benches, and this is configurable in the YAML files. But there is also an information about cluster layout buried inside run-cbt.sh. We are doing free We are doing free OSDs, if I recall correctly, and it's
So CBT use the Rados bench, right? Can I use the FIO
yes.
in CBT?
Yes, we can.
It will be yes. CBT can consume FIO, and Avnom added the generalized types per op metric, so it should be able to quite easily integrate with FIO, but this would still require some code changes, but pretty small, I believe.
Yeah.
So CBT, yes, can use for sure. What is for sure? CBT can use FIO. Crimson does support very basic FIO.
Radek, I think
but
I could copy you, include you in the loop where Trimi was asking for help regarding to the performance test. And we can discuss this offline.
I think Riddle's already in the loop, I think.
Okay.
I think so, but maybe there was some new conversation. I don't know. Do you mean the mail from last week?
Yeah. So please give me some instruction because I didn't use CBT before, so it's new to me. And how to
okay,
CBT.
I posted.
Yeah, sure. I will
posted,
try it.
I've sent this in the response. It's very straightforward.
I think you could give the run CBT script a try, and if you run into any issues, you can just
okay.
Yes,
let us know.
Start from run CBT.
Yeah,
but
you.
keep in mind to get both freshest CBT repo and freshest Ceph repo, because the Avnom changes for Ceph has been merged pretty recently, last week, maybe beginning of it, something like that.
Your latest CBT.
The latest CBT is already merged in master branch, right?
Yes.
Just download the master Ceph master branch is okay, right?
Yes.
Yeah, thank you.
Okay. And Ronan.
Yeah, almost forgot that I have a part by myself. Still doing scrubbing, but actually mostly testing and reading code to see what was done, learn some of the tricks that were in the services that were used to make code. So nothing much new here. What I would like to know is, I saw that, is this the first upsell service that we were using? What you just brought in?
The first episode stuff was the B-tree implementation.
It was upsell originally?
We are using the B-tree implementation from episode.
Okay, so so we are not against using upsell code.
I'm not sure. We are not using upsell as a library as a whole, but we are just to grab the interesting bits from upsell and adapt it to our needs, because upsell is supposed to be C++ 11, but now we are using C++ 17. So
Ronan, to be clear, there are no hard and fast rules about what libraries we permit and not. If you have a reason to use a library, then we'll talk about it. Like that's just how it goes. It's not like there's a specific whitelist. It's just when we think there's a good reason to do it, we discuss it and then we make a choice.
Okay, good, thanks.
along the
So
licenses
nothing,
allows us to do so.
of course, no GPS 2 3. Yeah. Yeah, so more or less, this is where I am.
Sam,
I got sidetracked with some other stuff about deduplication last couple of days. Earlier last week, I have merging working with the LBA tree, so I need to do a bunch of cleanup and documentation. And I need to do a more thorough review of Kifu's code, and I think I'm going to do that basically by trying to use the layout.h implementation in LBA. It's just easier. It's a cleaner, simpler implementation. It doesn't actually change very much code. It doesn't do any of the splitting and merging, obviously. It'll just replace the iterator interface I was using. That's it for me. I'm going through the Crimson backfill stuff. And I think I owe reviews on a few other things too. So I've been working on reviews as well. That's it.
thank you. Johan,
last week I was still spending my most of my time refactoring the clean shutdown. And this week I think I can concentrate much more on the recovery related code. That's all for me.
thank you for taking care of the Griff shutdown. It's a large PR. And by the way, I encourage the team to take a look at the Johan's Griff shutdown.
电解口直接插上去了是吧？啊，那
Yeah, I'm trying to last week I'm trying to understand the concurrency requirement at the tree level, and I was looking at possible solutions. But as the discussion goes on, it seems to me this requirement is currently relaxed. And later, I'm majorly reviewing Kefu's node code and the clean shutdown PR. That's all from me.
Thank you, Yixing. By the way, Yixing, I just wanted to be clear. I'm not trying to persuade you into to abandon your work in progress. I just want to emphasize that it will be hard because it's it's currently the node without asynchronized support is like 3,000 lines of code. So
yeah, I think we are currently working on different directions. You are on the solution, and I'm trying to work out how to do exactly from what Samuel's proposal.
Yes, I try to as close as possible to Samuel's original design and to simplify the design and to get it merged ASAP to unblock the other guys.
If you can improve it, you should certainly do that. You don't need to stick to things that seem dumb, right? But Kifu, to clarify, your implementation is meant as a stopgap so that we can continue progress elsewhere, right? It's just supposed to be a simple fill-in.
Yeah.
Is that correct?
I think so.
Okay, cool.
By the way, if you need to have a better name or have a better structure regarding to the layout of the directory and the source file, please let me know so we can adapt the directory layout to your needs if you want to plug in another implementation of the ONode tree.
ONode, or what I call it, the ONode manager, I think I meant it to be an interface, if I recall correctly. So yes, there's no reason not to interface it out. I just have two implementations. You can just do what I did in the LBA subdirectory. You'll notice there's a B-tree subdirectory under LBA manager.
Yeah, the intention is come up with a better name than B-tree.
No, the point is that there may be other implementations later. For instance, for persistent memory, it might not look literally anything like a B-tree. There might not be a tree. It might be simply a statically allocated subset of persistent memory with direct updates. That's the intention there. Like on other media, right? It might be wildly different.
Okay. But yeah. I'm just struggling with the name. What the better name I could come up with, because
it is B-tree.
But Nginx implementation would be also B-tree based.
Yeah, but they'll be in different namespaces. It's fine. It's fine.
Okay.
You can come up with a good name though.
Yeah, I just think that the level is
amazing tree. I don't know.
Okay, that's it. Anything else? Oh, by the way, we have also have an offline discussion regarding to the integrating the Sealang-based CI or CD.
Do we want to talk about that now? A little bit.
I'm fine.
Okay.
So my suggestion still holds. I think it's the less intrusive change and the most with the least risk.
You mean just modify one of our tools to just do it? Oh, switch the whole thing over.
Yes. Or not switch the whole thing and just switch the performance test.
That's what I meant. The whole performance.
Okay. The make check boot.
No, not the make check.
Crimson
check.
That...
Yes, the Crimson one. The Crimson.
Yep.
The perfect test for Crimson. I think that would be the simplest thing to do at this moment.
So just one.
Do we have 2 nodes there?
We have 4 nodes.
Or a single one?
4 nodes.
4.
Center, I think.
What about? Yes, I can recall that the old make check bot for ARMS were using two different arrangements. One was on Ubuntu, one on CentOS or something like that. They were differentiated anyway.
Currently, so all the test nodes running performance test are CentOS 8, if I recall correctly. They're using the identical hardware setting and software setting.
Okay, I see. But maybe it's not the requirement. Maybe we could differentiate, like in the case of old ARM64 check. And then, if we could somehow label which one is which, then the Sam's point about being about
no, if they're running the same compiler, I really don't care. It's not worth it. Just have them. If they both run Clang, that's great. Like, don't overthink it.
Okay.
I just didn't necessarily want to be doing performance comparisons of Classic compiled with GCC against Crimson compiled with Clang. But if they're both compiled with Clang,
okay.
That'll be totally fine.
Okay, apple to apple.
I just didn't want to mix compilers. But yeah, if they're both compiled with Clang, that's perfectly adequate.
Okay, we can switch pretty easily, I believe. The question will be, what next? Okay, let's suppose it's operational and Crimson is getting more and more audience.
More and more what?
Somebody make a change, and this change fails on Sealang. Sealang isn't so popular. Most folks, my impression is that most folks go with GCC. So
okay.
we will start blocking people and asking them to tune themselves to Sealang. Maybe we really should have some automation for contributors.
We do. The automation is the performance test. It's good enough. Let's not overthink it.
Install deps.
No.
Or then yes, fine. Right? The install deps file. It's not rocket science. Like this isn't a huge deal.
We should have this.
So good with starting with the Crimson performance test. If Rita, you have any other ideas we could itemize using the Trello card, and we can discuss using offline using mails. How about that?
To be clear, I'm pretty sure the only remaining one is Clang and Clang++. Those are the only dependencies that aren't already listed. That's all I have to install anyway.
What dependencies?
Just Clang itself.
Yes.
I think that's the only difference. That's the only change I have to make it work locally.
Just to pass a different. Yes, C++ compiler.
That's true. So I think install deps needs an argument that has.
Yeah, do CMake for Clang.
Hang on. Install deps needs an argument to have it install Clang, and do CMake needs an argument to use Clang instead. I think that's it.
Yes, I agree. Probably we also need to pass the CMake underscore C compiler to
yeah, exactly. But you can do it
as well.
You can do it in do CMake.sh. That's what I'm saying. If you give it an argument,
that's true.
Use CMake.
Yes, that's also what I'm doing now.
By the way, if I remember correctly, we are not using Ninja for as a default, right?
No.
We don't.
There's pretty much no way we're adding another build automation tool. CMake took like 2 years to integrate. It was
no,
Ninja is like
it's a make and it's much faster. The idea is that I'm using it already. When I'm building with Clang, I build with
Ronan,
the target.
If we want to make that work, we have to make it work on like a bunch of different platforms. We have to make it work on several different versions of Ubuntu. It's just not worth it. Like, that is so much work. You'd have to talk to the build CI team and see if they want to support that. They're not going to want to.
No, I'm not thinking about
I don't think you get the point. It's a replacement make.
I know that. I'm saying if he wants to replace make, he's welcome to. But if we have a problem, like if a problem arises out of doing that, I don't think we're going to fix it. In other words, if it works in your environment, Ronan, by all means, go for it. But we're not going to switch to the default.
No problem. What I meant to say is that I will continue using Ninja here on my laptop because it's so much faster. So it might just mean adding an argument, an optional argument to the do CMake. That's all.
Yeah, we could do that. I've been using it for like 1 or 2 years.
Okay, just make sure you ping the appropriate maintainers and make sure it's not going to cause problems. That's all. Seriously, like, there are just a lot of platforms and it's a huge pain. That's all.
Great.
Understood.
And this also affects Clang as a whole. I bet we don't want to claim we officially support Clang builds. Otherwise, we would need to get it into tautology testing, and well, it will be.
I think we can go as far as making a point of, for one thing, it is useful to build with it. It captured a bunch of Lambda default things that sometimes we notice in review, but we usually don't, and that's worth the price of admission on its own. So we don't have to go past just using it locally and checking it with the perf test. I think that gets us like all the bang for the buck we needed, and we get to continue using GCC, which usually has better performance anyway.
Agree. I'm not sure about the performance though. But
it depends. It depends. Phoronix does these tests every so often. Usually GCC is a little faster. It depends. I mean, the resulting binary is faster. The compile is way slower.
Yes, I agree.
That won't always be true, but it appears it was true the last time I checked for most purposes.
Okay, so we agree on everything.
More than what Clang is doing now. What makes it slower and then more hungry regarding to the memory usage. Anything else? Okay. Thank you, guys, and have a good one. Talk later.
Thank you, and see you later. Bye.
See you.
Bye-bye.